Hello student, how are you? Hope you're fine and doing great. Okay, in this video, your teacher Ziaul Haq. In this video, we are going to study about the condition for equilibrium. We have two condition for equilibrium. First condition and second condition for equilibrium. In first condition, usually we are know about the static equilibrium. Like first condition mean like the static equilibrium, and the second one is like dynamic equilibrium is happen. Okay, let's see one by one. Like what is first condition? First, we are going to study about know about the first condition, and this after this, if we are going to know about the second condition. Okay, let's see one by one what is the first condition and what is the second condition for equilibrium. Okay, let's see the first one. A body is said to satisfy the first condition for the equilibrium if the resultant of all the forces acting on it is zero. Same like in the equilibrium video, like if we have the object but there are applied the force in different direction like upward, downward, left, right and left, but these all forces are if we sum these all forces, let's suppose this is F1, this is F2, this is F3, this is F4, but if we sum like if net will be equal to 0, but like this one is equal to 5 Newton, this one is also 5 Newton, this one is 3 Newton, this one is 3 Newton. If we add these all forces, if net mean total force on this object, but their sum is equal to what? 0. Like how? If 1 minus, like this is the opposite of this force, minus if 3 plus the second one like if 3 minus, this is the opposite, minus if 4 is equal to, if net mean these all forces is equal to 0. So this is equal to 5 Newton, this is equal to minus 5 Newton plus this is equal to 3 Newton, this one if 2, and F4 is also 3 Newton, but both are in the opposite direction. So 0 plus 0 is equal to 0. So we can say if the sum of these all forces acting on the object toward on axis direction, like this is the horizontal side where the forces are applied on this object, and this is on the vertical direction. So we can say the sum of these all forces when acting is it on 0. So let the number of forces mean how many forces are maybe like another this force, this type applied on this direction, different direction. So many forces are acting on the body such that the first condition for equilibrium can also state it in term of x and y component of the forces acting on the body is. Like in next page we will know like what is x and what is y direction. So if the sum of these all forces is equal to 0, so we can say the object is in clear the first condition of equilibrium. Okay, let's see again here. Here is they mentioned it f1x, f2x, f3x. For example, let's see this diagram. One force is applied, like this is f1 xy, the given name is x because it is on the horizontal side. This is f2 x, and the other one f1 y, f2 y, and so on. Like the force is also applied on the f1, let's suppose this is f3 on the y direction, and this is also f4 on the y direction. If we add these all the forces, like the sum of these forces on the horizontal side is also equal to 0, and the sum of y direction mean this one is also equal to 0. So we can say like if net on y side is equal to 0, or if net on x side is equal to 0. So the object must be in the first condition or clear the first condition of the equilibrium. Like this is the simple notation of the first condition of the equilibrium, like sum of all on the x side forces must be equal to 0 and the sum of all on y side forces must be equal to 0. So if this object clear this condition, so we can say the object is in first condition of the equilibrium. Okay, let's see some example of the first condition of the equilibrium. Here are some example of the for the first condition of equilibrium. Okay, the first one is a book lying on the table. Like let's suppose there is a book in lying on the table. There are one force, one is weight and the other one is normal force. There are two forces on the y direction. Let's suppose f of n on y direction and f minus the weight is in downward, f of w on y direction is equal to 0. So we can say like that there are two forces acting on the book which is laying on the table. So this is the first example. The next one, a picture hanging on the wall or the rest and thus satisfy the first condition. Like there is a picture is hanging on the wall, so also clear the first condition of the equilibrium. Okay, let's see here. Here is a simple example. Like this is the lamp. The lamp weight is 8 Newton. What they want? A lamp, 8 Newton lamp suspended from the ceiling. Ceiling mean this rope by a cord, negligible mass. This is called cord. This string is a traced form. Find the tension in the force. So they want the tension and the weight is downward, which is equal to 8 Newton. So we know that if we want to finish, if we do the first condition of equilibrium, the sum of all forces on x side or y side must be equal to 0. But here the two forces is applied on this lamp, but in which direction? In vertical direction. So we can say force on the vertical side there is tension force, and downward here is weight. This is also force plus, but the weight is in negative direction, so this is equal to 0. So we can also write the equation T minus W is equal to 0. So the weight, putting the value of weight which is equal to 8 Newton minus 8 Newton is equal to 0. So tension is also is equal to 8 Newton if we shift the value of weight. So this is the example of the first condition, simple example. Inshallah, in next video we are I am going to solve some more example which will clear the first condition and second condition, some more example. But in this video just know about what is first condition. Again, let's see, when the sum of all the forces x6 on the x direction and y direction and their sum is equal to 0, so we can say the object is in first condition of equilibrium, or clear the first condition of equilibrium, but the object is in rest form, static form. Okay, thank you so much, dear student. If you have any questions, so you can ask in your comments. So thank you so much.